Okay, am I... So that I bumped the camera. Okay, so now, how do I use the 4x4 case to move up now to the 8x8 case?
Well,
what do I know now?
You know that you can use the 2x2 case to make the 4x4 case. You know it works as long as you block off a
Okay,
block.
so what is the 4x4 case? Let's say that out loud.
4x4
case is...
It consists of 5 of these L shapes, and then 1 square is blocked off.
Okay, so what we've shown in the last step was any 4x4 square that has what properties, what can happen?
Has one square removed can be filled with these L's.
Okay.
3 square L's, yeah.
And now we're going to try to use that to show what?
That any 8x8 square with 1 square blocked off can be filled in.
Okay. How should we do that?
Well, if you pick any square on the board, it'll always be in one of these quadrants.
Okay.
And in that quadrant, you have the 4x4 square.
Okay.
And we know that can be done as long as you block off a square, which we have.
Okay.
And then, so once you fill in that 4x4 square, you build 3 other 4x4 squares so that all of the blocked off squares that are actually not blocked off are in the center.
Okay.
Here.
So
and then from there you just
would you like to
fill in.
identify them with that? So that yellow represents the squares you're blocking off in
the 8x8 case.
Okay. So no matter how we build the 4x4 case down here,
It doesn't really matter
why?
because we know it can be done.
We know it can be done.
Yeah.
Okay. And then what does that leave us with?
We can just build 3 more of that and then build them so that their squares line up in the center.
In what shape?
In this L shape.
In that L shape. Okay. Interesting. Do you have anything you'd like to add?
No, that's pretty much it.
Okay.
You just choose where to emit the square so they line up here, and then since we solved every case for the 4x4, you know you can build the squares out of the pieces that remain.
All right. So let's do that real quick since we have.
So I guess
You can.
You should build them.
You build over there. You build down here. Can you reach down?
Yeah.
And I'll build up at the top.
Like this.
All right. There we go. There you go. There we go. All right. So we can do it.
Yep.
Okay. So now we've done the 2x2. Actually, we did the 1x1, 2x2. 4x4. Now we've shown you can always do the 8x8 using the 4x4.
Yes.
Now how do I show I can do any 2 to the n by 2 to the n now?
so you can. I guess you can. Is it induction? Is what it's called? You assume it's true for a 2 to the n by 2 to the n.
Okay.
And then you know that the 2 to the n plus 1 by 2 to the n plus 1 is made up of 4 2 to the n's.
Mm-hmm.
And you know you can solve what we just solve the bottom left 2 to the n because that's the case we used previously. And then you omit the 3 other middle squares and then build 3 more 2 to the n's around them and then connect up the 3 middle squares.
Okay, cool. Yeah. And there's one extra step you left out for mathematical induction. Mathematical induction has 3 steps in it.
So you assume it's true up to n.
Uh-huh.
And then you prove it for n plus 1.
Those are 2 of the 3. But there's a 3rd step.
And then is it so it can go up infinitely?
Nope.
We need to prove it for the first one.
You have to check that it's true in the beginning.
And we've done that.
So you check that it's true in the beginning because your first step can't be assume it's true.
Yeah, you have to actually prove it.
So you check that it's true in the beginning, and then you show you can walk up a ladder. And why do you think that shows it's true for all integers?
Well, because n can be whatever you want it to be. And then n plus 1 just follows from n, and then you keep going out. N plus 1 becomes your new n.
Why do you think it works? Why do you think mathematical induction works for problems like this?
Well, you've shown that the next case is built on the solution for the previous case. It's sort of we built the 8x8 using essentially 4 of the 4x4s. And that will always be true as long as you go up an integer each time you go up a step.
Okay, interesting. So it's neat. It's a initially this problem seems almost intractable. Right? I mean, how I can't check that I guess theoretically I could check 128 by 128 square, but obviously I can just make that even bigger, like a 1024 by 1024 square. There'd be like, seems like that would be very difficult to check, but it turns out the easy cases tell you how to build up to the larger cases, and there we go. All right, good work this morning, guys. This is a nice exercise in beginning proof techniques.